morning, guys. The last thing that we're going to look at in this introductory lesson of Chapter 7 is how to determine if the solution to a system is no solution, one solution, or infinitely many solutions. Now, we have mentioned this all along, how to determine what's going to happen in a system when we graph simply by looking at the equations, but we haven't worked any actual exercises that ask us to do that. It was just one of the things that we looked at in the process of solving a system while graphing. But let's go ahead and do that now. So let's look at this example. It says without graphing. Now, I don't want you to graph, okay? There's no graphing involved in this. It is all looking at the equations. Without graphing, determine whether the system of equations has one solution, no solution, or infinitely many solutions. Now, sometimes your system of equations, the equations are going to be all given in slope-intercept form. Sometimes they might be in standard form. They might be in point-slope form, or they could be mixed. You could get one that is in standard form, one that is in slope-intercept form, and that is like the example that we're going to look at here. Regardless of what form your equations are given in, you need to know the slope and the y-intercept. And to determine the slope and y-intercept easily, we need them in slope-intercept form. So let's look at our system that we have here. Our first equation is 2x minus y equals 3. That equation is written in standard form. So we have to rewrite that equation in slope-intercept form so that we can see the slope and the y-intercept. Let's look at the second equation. We have y equals x minus 1. This equation is already in slope-intercept form, and it's very easy to see the slope and the y-intercept. But let's go ahead and rewrite this first equation. Okay, so step one in this process is to rewrite the equations in slope-intercept form if they are not already in that form. So when we take 2x minus y equals 3, we have to isolate the y, so we subtract 2x from both sides. We're going to take this 2x and move it over here. That leaves us with negative y equals negative 2x plus 3. And the last thing to do is get rid of that negative sign by dividing or multiplying by a negative 1 on both sides. So when you multiply both sides by negative 1, we get y equals 2x minus 3. This equation is now in slope-intercept form, and it's very easy to see the slope and the y-intercept. So let's write these down. Normally we wouldn't have to write them down, but for the demonstration purposes, we're going to write them down. So here we go. The first equation, y equals 2x minus 3. It has a slope of 2 and a y-intercept of negative 3. The second equation that was already in slope-intercept form has a slope of 1, there's a 1 right there, and a y-intercept of negative 1. Now that we have these slopes and y-intercepts, all we're going to do is compare them. So when we compare these, this is what we're really looking at. We have said all along in this lesson that if the slopes of the equations are the same, then the lines are parallel if the y-intercepts are different. So the first question we ask is, are the slopes the same? Well, we can plainly see that 2 does not equal 1, so the slopes are not the same. So that means that the lines are not parallel, so that means that there isn't going to be a no solution response to this question. So we know that there's either going to be one solution or there's going to be infinitely many. Now here's the next thing that we look at. Are the slopes different? And we can see that they are. If the slopes are different, then we know that there's going to be one solution. If the equations, the slopes and the y-intercepts were the same, then we know that we have infinitely many solutions. So these are the three things that you need to remember. If the slopes are different, then there is one solution. If the slopes are the same, but the y-intercepts are different, then the lines are parallel and there is no solution. If the slopes and y-intercepts are both the same, then they are the same line. And if they're the same line, that means if you were to graph them, they would intersect everywhere, and there are infinitely many solutions. So using these three conditions, what can we say about our system of equations? Well, since the slopes are different, we know that there's going to be one solution. So that would satisfy this first bullet right here. So one solution. Let's look at the next question. It's just a think, pair, share. Without graphing again, how can you tell if a system has no solutions? Give an example. Well, if you use what we just said on the last slide here, we said if there is no solution, which is right here, that means that the slopes are the same, but the y-intercepts are different. So they ask you in this question to tell, you can tell if a system has no solution, and then give an example. So when you give an example, you just need to write a system of equations where you have same slopes and different y-intercepts. And this here is just one example of many. And again, the reason that it has no solution is because the lines are parallel. They do not intersect. And the only way you can have parallel lines is if the slopes are the same and the y-intercepts are different. Alrighty, that's it.